Is that better? Don't want to slight the viewers at home. Hey everyone, so my name is Brad. I am a UI programmer doing React and React Native at a company called Spreadfast, based out of Austin, Texas. If you do anything with social media, you probably know about them. What we're going to talk about today is What we're going to talk about today is kind of how the JavaScript bridge works on iOS specifically. So only about 25%, I guess, a rough estimate of you kind of raised your hands there and said that you've used React Native before. So just as a clarifying question, what is React Native? This is the basic idea here. You write React, your application is a React application, and that renders as native views instead of DOM elements, instead of compiling down to HTML and CSS and JavaScript. What you're compiling down to, what's actually running on the device, is a native UI view or the equivalent on Android. And so we'll that's like the gold standard. That's like a dream, right? For UX and performance. How does that work? And if you're anything like me, you want to sort of understand the system as a whole before you really feel comfortable using it. So this talk is going to be kind of a narrow, deep dive to see how we might build something like this on top of what's available. So what makes this possible is JavaScriptCore on iOS, at least what made it originally possible. And so just want to clarify here, there's a JavaScript engine, that's Apple's JavaScript engine, that's called JavaScriptCore. That's not what I'm talking about here. They have another library that's the interoperability APIs between the JavaScriptCore runtime and your native code. And that library is what we're talking about here. And there's two main classes to think about. The first is called JSContext, and the second is JSValue. And we'll look at some examples of them now. So JSContext, wow, this contrast is really low. At least you can see the highlighted code. So this is Swift code, so if you're confused, you feel free to ask questions if you're totally confused. Hopefully it should be pretty clear. We import JavaScriptCore and we create a context. Is there any way we can increase or decrease the contrast on this projector? Maybe we're working on that. Okay. Create a context, and then once we have this context, we can ask the JavaScript context to evaluate some script. So we say context.evaluate script, and we pass it a string of JavaScript. And what we get back is a JS value, which we'll talk about on the next slide. So we can run some code. We can also put some data into the context. And so what we're doing here, context.setObject, we pass it a value. Sorry, this would look better if you could see all the rest of the code. Set value for keyed subscript x. And so if I back up a second, what this is doing is it's saying, okay, now there's a global variable called x, and its value is set to 2. And so now that we have run our call to set object for keyed subscript, we can say, okay, context evaluate script 2 times x. And now that doesn't blow up because x is defined. We've defined it from the native side, inside of our JavaScript context. So what are JS values? If we run this again, we get back something that is a JS value, and we can do some conversion on that value. We can say, give me a string, and this will return you a native string. We can say, give me a number, to number, and this will give us, in this case, a Swift number. We can inject functions and call them, so let's see what that looks like. Let's say we have this snippet of JavaScript code which defines a function times 2, and we evaluate that into the context, and then we can notice that we receive a value every time we evaluate the script. So the result of the expression will be returned to us as a JavaScript value, and any side effects will still remain inside the JS context. So we have, in this case, a handler to our JavaScript function from the native side, and we can ask that JS value to call itself with certain arguments. So we say times 2.call with arguments, and we pass it an array with the value 2, and that JS value that we get back, we could say to number 4. We know what that is. Great. So let's look at a super simple demo. We know enough here to build sort of a simple REPL, and we can see kind of what this looks like. This is available on my GitHub if you guys want to download it and play with it and see what it looks like. So I didn't anticipate having one hand while live coding here. So 1 plus 1, 2, proof. Let's see. Let's do something more complicated.
For this part, at least.
Yeah, that'd be great. Thanks. So let's do math.min. Let's see if that's available. Actually, first let's just see if math is available. So yeah, so there's some standard library functions and modules that are available to us. And just to prove that they work. Oh, forgot a comma. I'm coding blind. Okay, proof, good. Let's see what's not here. Thanks.
We could probably raise this.
Let's see what's not here. So fetch, it's not there. XML HTTP request.
Do you want to do this?
It'll be over in 2 seconds. Thanks.
The pain will be over.
Fetch, thank you. Fetch is not available. XML HTTP request is not available. Things, obviously the DOM APIs are not available. So yeah, you can download this and play with that. It's a quick example of the REPL and what's there. So let's get on to trying to build something like React Native. So what about React? Well, if we tried to build everything about React Native right now, we'd be going down the rabbit hole, right? Let's try to do something a little bit simpler. What's the important part? What's the value proposition? It's this virtual DOM, right? We want to render, we just want to re-render when everything changes, and we want to let the framework diff and patch our updates for us, right? That's the big value proposition. So there are many other competing libraries now to React. There's Preact, and there's Inferno.js, and there's also Virtual DOM, which is lower level, which gives us the primitives that we need to implement this ourselves. So let's take a look, and in fact, that's what Preact does. It uses Virtual DOM under the hood. So let's take a look at what that would look like if we wrote an application like that. So we first import some things from Virtual DOM, and I'll explain what those are. H, don't worry about H, that's going to let us, that's going to transform our JSX into something like React DOM calls, right? Something called hyperscript. Don't worry about it. It makes our JSX work, okay? Create element, and diff, and patch. Those are the 3 main functions that we're going to import from Virtual DOM, and we'll see how those work. We're going to define some, these are essentially just tag names, but components that we'll use to sort of be the high-level language of our application. And here's our app, right? We have a counter app. It's just a function. It takes props, it takes a count and a function increment. And we render a view, we render text with the current count, and then we render a button that's labeled increment that when you click it, calls our increment function. Very simple app. Here's our initial state, count is 0. We render our app, and that returns us a virtual tree. And then we can pass that into create element. That came from Virtual DOM. That will actually generate a DOM element for us. And then on the website, we would take that DOM element and we would append it somewhere inside of our document, right? So updates. Obviously, this is our business logic. Very simple. We increment count. And then you can imagine the rest of this happening something in like a store subscribe in a Redux app or something, letting the framework take care of this, but we're going to do it ourselves. We just re-render. We pass in our props again. We get a new virtual tree. We call diff, and we pass in the virtual tree, the old virtual tree, and the new one that we just generated, and we get a patches object. And we can pass that to the patch function, which also came from Virtual DOM, and that will return us a new DOM node. In this case, it'll actually do it in place for us. And then, okay, great. Let's take a look at what the vtree and the patches objects actually look like. What's in a vtree? I wish you could see the rest of this. We can't. Okay, never mind. We'll just plow ahead. If anyone knows how to turn the contrast up or down on the projector, that'd be great. So the vtree is a list of virtual nodes, and a virtual node has basically 3 things. It has a tag name, has properties, and it has children. And the children is a list of other virtual nodes. This is a recursive data structure. It's turtles all the way down. Tag name, properties, children. Tag name, properties, children. Okay? So that makes sense. vtree, recursive data structure, tag name, properties, children. Very simple. So what's in a patch? If we look at a patch, this key here is a node index. And I guess I'll stay here because it's clearer to see. It's a node index. So you can imagine if you took your tree, your UI tree of nodes, and flattened it out, that this could be an index to get you to a particular node in your tree so that you know how to find it and then run some operation on it. The properties of this patch object that's at that index. You have a type, which represents what type of transformation is going to happen. And then you have, so node index, patch type, you have the previous value of the node, virtual node, and you have the next value. So let's back up. The API here, we have create element, we have diff, and we have patch. And there's really only three places where we're referencing the DOM, right? In create element and in patch. So just imagine that we replace where DOM node appears with UI view, right? We'd have it done. We could render our app as native views. So what does that take? Let's look at create first. Create is a function. We're going to take our root, which is a UI view, and our tree, which is a JS value, like we talked about before. And our base case here, this is going to be a recursive function. Our base case, we're going to look at the type, and if it's a virtual text type, the node is a virtual text type, we know that either we're going to set the text value of a UI text view, or we're going to set the label of a button, right? This is really quick and dirty. Once we've handled that, aside from our base cases, we're going to need to create new nodes. And so we look at the tag name of those virtual nodes, and if we have text, we're going to generate a UI text view. If we have a button, we're going to create a JS button, which we'll take a look at in a second. It's just a UI button, but we're going to do something special. And once we create that JS button, we're going to set props on it, and we're going to pass in those properties. Remember, tag name, properties, children. And so we've done tag name, we've done properties. If it doesn't match anything, we're just going to default to a generic UI view. We're going to add the view we just created to the root that was passed in. So we're doing these changes in place. And then we're going to recurse to the children and do the same exact thing. So tag name, properties, children, recursively creating views, setting properties. You can see how that works. So let's take a look at our JS button real quick. It's a UI button subclass, and it's got a field properties. And set props is going to set those properties on our instance of the object. And then if it has a property, OnClick, so in that virtual tree, if there's a JS function in there named OnClick, we're going to add a target here. This is a bunch of iOS gobbledygook. Essentially, when you tap the button, it's going to call this OnClick function that we'll look at. And so when OnClick is called, we're going to look at our props. We're going to get the function value out of the props for OnClick. And remember, that's going to be a JS value. That's a function, so we can call it. We saw that before. So we call with arguments, and in this case, it doesn't take any arguments. And that's all it takes to get that increment function actually called when you click on it, or when you tap on it in this case. So let's take a look at patch. We rendered our app, great. It's not updating when we click the button, even though our JS state is updating. How do we make this work? So here are our patch types. We don't need to worry about all of them in our case. In our case, we're only ever going to do a virtual text update. But these are the different types. Apply patch is essentially the equivalent of that patch function. So we're going to take a patch object, and we're going to take a node, which is a UI view, and we're going to grab the type from it, and we're going to grab the current value of the node, and we're going to grab the next value. Remember, we're looking at those patch objects, type, current value, next value. And man, these code demos were so cool. If you could just see my screen. All right. And then we're going to switch on that type. And if it's a text type, we're going to run our string patch function. We're going to pass it the node, we're going to pass it the previous value, and the next value. So let's look at what that looks like. We've got the node, we've got our previous value, and our next value. We're going to grab the text. So this is inside that patch info. Yes?
Is it possible to change your background color, please, for the lights?
I don't know, would the lights help?
The light. I don't see anything on there at all.
Are you able to highlight text on your screen?
Try and highlight it just for your mouse.
Let's see. Yeah, I mean, it's not helping. Can we not turn the lights off? Is that not helpful?
I don't think the lights are going to help. They're showing up
Major fail. All right. You're just going to have to trust me that what you can read is all you need to be looking at right now. Trust me. So our string patch operation, we've got our UI view, which is our node. We've got the current value of that node and the next value, the patch information. So we grab the new text out of our patch information, and we set the value of the text view. Oh, I did highlight it. It's just, you can't see it because of the colors. And we set the value. We get the new text, and we set the value inside of our UI text view. And just to prove that this works, and stop the bleeding here, we'll run our demo, which is incredibly exciting, I know. This is also available on the GitHub if you want to take a look at it. I know that's super exciting, wow. Okay, so we essentially built a very small, narrow slice. We went all the way to the bare metal. We ran our JavaScript application as a native application. But what's missing? Obviously, there's a lot missing. Layout. You can see in that demo, I cheated. If you look at the source code on GitHub, I cheat for layout and how that text field looks. That's a big task, right? That's something React Native gives you. They implement Flexbox and some subset of the CSS spec. That's a lot of work to do that. The best way to do layout, maybe you decide you don't like Flexbox and you want to do it another way. Maybe you want to use auto layout, right? You could have gone some other way, but that's something that's missing from this that's in React Native. Debugging tools, obviously, we didn't do any of that here, but React Native lets you have remote debugging and run inside of Chrome and do all that fancy stuff. We don't have any UI library here. We're not touching any scroll view, table view, anything like that, so we would have to be able to bridge those as well. We did a little bit of that with our button, right? But we'd have to obviously build out the rest of the UI library to build anything useful. And then obviously, this doesn't touch on Android. One quick note about Android, it actually is also running JavaScriptCore, the JavaScript engine, not this interoperability library. It's confusing that they have the same name. They actually package up the whole JavaScriptCore runtime and deliver it with your application. And so the nice thing about that is you're running a consistent VM between platforms, right? So that's kind of nice. The exception to that is when you remote debug in Chrome, your app is actually always running fully inside of Chrome. So that's V8, that's not JavaScriptCore. You could have some weird things there. Anyway, so what we understand now is we understand JavaScriptCore on iOS, JSContext, JSValue. We know how to put data in. We know how to evaluate scripts in the context. We know how to put data into a context. We know how to call JS functions and get values back from that context. And we have also a little bit of more understanding potentially of how DOM diffing and patching works as well. Yeah, that's pretty much it for me. I didn't time myself, but hopefully we're good on time. Okay, cool. So any questions? That was a lot. Went really fast, but any questions? I apologize again for the code. Please check out the slides on GitHub if you were super confused and lost. It's much clearer if you read it on stream. Yeah?
Do you have experience using Swift or Objective-C prior to using React Native?
Very limited, only hobbyist level.
Do you find it easy to transition into React Native?
In transition into React Native, yeah, absolutely. So I do React all day, every day on the web side, and also now in React Native. And it's the things that are very different are styling and layout. Only that you have to, if you've never done Flexbox before, it's very different, right, than the way things used to be. So learning that Flexbox is not CSS, it's a different thing. I mean, it is CSS, but you know what I mean. That was a big difference. And just having your styles in line is a big difference. But yeah, it's a pretty, if you know React, you know React Native. And that's really the idea of it. Any other questions?
I'm a real neophyte with this React Native, but I've been doing some React and your talk was.
Hello? Yeah, your talk was great, but I didn't really quite get the part with the Swift and stuff. I thought React Native would just build a React application, and then the render part, instead of putting out the HTML tags, it would put out different tags, and that's all I'd have to do. So I don't really understand much about it.
So this is certainly not how React Native works, right? We were re-implementing a bare bones version of what React Native does in order to understand how it works. Does that make more sense about what we're talking about?
That's great.
Okay. Sorry, I should have clarified that at the
You did.
beginning.
Now that you say it, I realize that you said that.
Okay.
Thank you.
Yeah. So there's a different, you know how on the website you import React and you import React DOM, and you write your application with React and then you do React DOM.render. It's just like swapping out React DOM for React Native. And then instead of rendering divs and spans, you're rendering UI views or whatever the equivalent is on Android. If that makes sense. Any other questions? Yeah. Or maybe we should.
Yeah,
Go ahead.
let's give him one more try.
Okay.
I heard you talk about inline styles a our React apps, we don't have any inline styles. We have our own style sheet for a component. Do you recommend doing that?
It's an overloaded term. I probably caused some confusion there. I'll hopefully clarify quickly. There's no CSS style sheets available to you on React Native. There is CSS, and you essentially create these style sheet objects that you apply as the style attribute to your React components, if that makes sense. But there's no like, here, require my CSS file, and then it cascades or anything like that. No.
Thank you.
On that topic, actually, with style sheets, I read somewhere that, like, for each component, the style sheet is loaded separately. There's no like global. Is that true?
So we should probably do a talk on styling React and React Native. What you're probably talking about is using CSS modules on the web. Again, having a CSS file and compiling that into something and using it on React Native, that doesn't exist. That's a web-only concept at the moment. And so what you're probably talking about is Webpack has support for the CSS module specs. You could have a separate file for each one of your React components and require that in, and it'll give you a unique class name so you don't have conflicts, and you don't have to worry about the cascade as much. Which is probably what you're doing. It's probably what most people are doing on the web. So that doesn't apply to React Native, I guess. Did I answer your question? I think so. Okay. Anybody else? Going once? Yeah, I'll go all the way back, I guess. My GitHub handle is B Spaulding. It probably is just easier to go to GitHub B Spaulding, and you'll find it there. There's a bunch of talks, a little presentation. Go all the way back. Any other questions?
Good. All right.
Great.
A round of applause.
Thank you very much, guys. Sorry about the code. Look at the slides online. It's much clearer. Thank you.
Actually, the screen turned out fine.
Okay, good.
Yeah, it turned out great on the screen. All right, and then the other thing I'll just note is that he mentioned quickly that JavaScriptCore is used on iOS, and they package it with Android. But what that gives us is it gives us a consistency between two platforms, a consistent VM, and we can use it.